Welcome. In this video, we are going to conclude the study of the integration by substitution using definite integrals, and we are going to see this example here. So imagine you're given this integration here in which you have to find what is the integration of such a function here. So this is a function of x, that's why we have here dx. So let us say they give you some boundaries 1 and 3. One thing we have to know is that these boundaries over here, they are points of x. This is our initial point of x, we can call as x initial. So it's from x is equal to 1 and integrate up to x is equal to 3. What this function actually means is not something random. This basically defines or determines the behavior of a given function. The function itself can be seen here. This is the graph of the function that we are dealing with. So we are going to take a point from x is equal to 1 till a point x is equal to 3, and all that area in between is what we are trying to find. So that means that we have this x, y, we have our 1 and we have our 3. So as we saw, ignoring all this part, the graph came as something like this. So we are dealing with this area. This is our area of interest. This is the area of interest. Fine. So this function here describes this curve here. This curve is defined by this function here, and the boundary of integration are decided by these boundaries we have here. These limits of integration here, they define from where and where we are considering. Now continue with the way of solving this thing. To solve this thing, we can only use integration by substitution. Why? Because if you pay attention to this, you see that this and this have a relationship. If you differentiate this one, you're going to get this one here. So this one we're going to consider as u. So u is equal to x squared plus 3. If you make derivative, it's going to be 2x, but this is a function of x. So this is a function of u and this is a function of x. Now what you're going to get is integration of, you are replacing whatever you have, this x squared plus 3 with u and these 2x dx by du. So you're going to have du divided by u. This is what you get here. Now this is a function of u, and what you can do is that you can solve this as we did without applying the limits, or you can apply the limits. So first try, let's apply the limits. Now to apply the limits of this is going to be our starting function. We're going to have here du divided by u. These boundaries here, these limits we have here are no longer u, because this function is no longer dx. It's no longer dx, so this is du, so they're going to be u, the values of u. So if I put it in this side, we are going to have du divided by u of upper limit. How do we do to find the upper limit of this function of u? We replace in this, attention to this expression which shows the equivalence or the relationship between u and the function of x. Whenever we have x, because this is our upper limit we want to find now, whenever we have x, we're replacing by 3, which is our upper limit. So we're going to have here 3 squared plus 3, which is going to give us 12. And then lower limit here, x was equal to 1. So we come here and in place in which you have x, you replace by 1. So we're going to have 1 plus 3 is going to give you 4. So then you can continue from here. So you have this function with these boundaries now. It's no longer described as this is another function. So what you're going to get is this, it's going to give us a logarithm function. So you're going to have what? You're going to have natural log of u and then our boundaries of integration from 4 to 12. Fine. And how do we solve this thing? We're going to make natural log of the upper limit 12 minus the natural log of the lower limit 4. That's what we're going to get here. Now if you know logarithms, we have some properties. If you have logarithm of something minus logarithm of something, it means natural log or logarithm of the first divided by the second. and this is going to give us somewhere around 1.0986. Fine, so we got the result of this using the application of the limits. Now let us say we don't want to apply this. Second case, we don't apply. So what you're going to get from this point, you're going to get what? From this point we already have du divided by u. So we don't apply the limits. So we come to, this is going to give us natural log of u. Fine, and we pass it to natural log of what is u? U is x squared plus 3, and our limits here are going to be in terms of x. They're going to be 1 and 3. See, this is now expressed in terms of x. We are replacing all the u's with this, and then our limits are going to be from 1 to 3, which were our initial limits of the function with respect to x. So this is going to give us what? It's going to give us natural log of, you're going to use the upper limit. You're going to have 3, you apply here on this x, you're going to have 3 squared, which is going to give you 9 plus 3, you're going to have 12, minus natural log, you're going to apply 1 here in place of x, you're going to have 1 squared plus 3, it's going to give you 4. So you're going to have a natural log of 12 minus natural log of 4, which you can just guess is basically the same thing as we had here. So this is natural log of 12 divided by 4, which is equal to 1.0986. This is how we would solve this problem here using this. We can also find a small problem. We can call this as our third problem, since we are wrapping up the topic. Let us say you have here natural log of x divided by x dx, and then we're going to put our limits 3, 2. You already know that these limits are x. So the next thing we're going to have is this. As you can see, natural log of x, if you make the derivative of it, you're going to have 1 divided by x. So we're going to take u is going to be our natural log of x. Derivative of this is equal to derivative of this, 1 divided by x dx. So which is this part here, right? So our function is going to become, in terms of u, this ln x becomes u, and all of this becomes du. We need to put our boundaries here if you want. In this case, you're going to just go straight with the boundaries. So what we're going to get here is u, you're going to now apply some limits of this, because we want to put no limits. Now our limits for x were this: x is equal to 3, x is equal to 2. Now if you take our function in terms of u, our limit is going to be natural log of 3 for the upper, we're replacing x by 3, and for the lower 2. So it's going to be natural log of 3, natural log of 2 of u du. And if you come here, this is going to be what? This is going to be u squared divided by 2, and then here you're going to have what? U is equal to ln 2 to u is equal to ln 3. Fine. And if you continue down, what you're going to have is, you just have to replace this, whatever have u, replaced by this upper limit. So you're going to have what? You're going to have natural log of 3 square divided by 2 minus natural log of 2 divided by 2, and this here is square. Fine. Now this is 1 by 2, we can take as common, 1 by 2 common, and then we're going to have here natural log of 3 square minus natural log of 2 square, and then this is going to give us 0.363. So we can solve this using x, which you can do by yourself. You're going to have the same result.